Hey ANPers, this is Dr. Jones checking in. This is ANP1 Lecture Test 5, Video 19, covering page 20. And I'm attempting to record this without the video of me in the hopes that it actually records. So I apologize for the lack of visuals, but I'm hoping to get this to actually record this time. Okay, so we are covering page 20 of the note set, which starts out at the top, the embryology of the brain, which we are omitting, I believe. Okay, here's our picture of the embryology. The relevant bit is this mesencephalon, which is what becomes our mesencephalon, which I have done a terrible job of circling both mesencephalon and midbrain. The prosencephalon becomes the cerebrum, and of course the diencephalon is the diencephalon. And then this bit becomes these bits. The cerebellum, of course, is its own thing. The pons, the medulla oblongata, and the midbrain become the brainstem. So, yeah, that gets messy. Moving on. All right, ventricles. Ventricles are CSF-filled chambers inside the brain. CSF is cerebrospinal fluid, like cerebro. Yeah. There are two lateral ventricles, one in each cerebral hemisphere, and here we have a better picture of the cerebral hemispheres. I'll try to mark on the pictures as I talk about things, since I guess that was the only way to point to them earlier anyway. Can't really track my eyes following the pictures, can you? Okay. Lateral ventricles, one in each cerebral hemisphere. There are two cerebral hemispheres, there are two lateral ventricles, and they are not midline, they are lateral. All right, that's how that works. So the septum pellucidum is not a ventricle, it's not a CSF-filled space, it's actually the thin membrane that lives like right here between the two cerebral hemispheres. We don't even see it on this picture. You see it right here. So it's this membrane right here between the lateral ventricles. It's in between the corpus callosum and the fornix, which is this white matter right here between the on fleek eyebrow and the hat is the septum pellucidum. And so it's odd on the list, on the lab list, because it's on the list where the ventricle models are, but it's not on that model at all. Okay. And then the interventricular foramen is this tube right here, like a little straw. And you can actually maybe see it better here. It connects the two lateral ventricles to the third ventricle. So lateral ventricles, interventricular foramen. And I'm going to switch to blue for the third ventricle. The third ventricle is midline. It is mid-sagittal, and from this direction, for me, this one looks like the body of like an eagle or a dragon. Yeah, I get a sci-fi feel on that one. In which case, these two lateral ventricles, of course, would be the dragon wings. And then the interventricular foramen is the little shoulders where the wings connect to the body, which is the third ventricle. And as a reminder, this is a fluid-filled space. And so this circle in the middle of the third ventricle is actually a solid structure. I know it's a hole, but it's a hole in a fluid-filled space, which means it's a solid structure. It's a negative of a negative. So the third ventricle is in the diencephalon. It's actually between the left thalamus and the right thalamus. So quick note, you have two thalami. You have a left thalamus and a right thalamus. The cerebral aqueduct is also called the aqueduct of midbrain, which I think is a really handy name because it runs down the middle of the midbrain. I'm going cyan for cerebral aqueduct. That's such a nice color. And this is, for me, that looks like the long, skinny eagle leg. Yep. And then the fourth ventricle. Oh, the cerebral aqueduct connects the third ventricle to the fourth ventricle. Oh, let's have a hot pink fourth ventricle. There we go. So the fourth ventricle is between the pons and the cerebellum. And for me, that one looks like the feet at the end of the long skinny leg. Or maybe the branch that it's sitting on. Yeah, going with it. And the fourth ventricle, let's see, between the brainstem, yeah, because it's also between the medulla oblongata and the cerebellum. So let's go with between the brainstem and the cerebellum. And I just want to say really quickly, just remember this is the cerebrum, cerebellum, cerebrum, cerebellum. What are the two halves of the cerebrum? Cerebral hemispheres. What are the two halves of the cerebellum? Cerebellar hemispheres. So make sure you get really good with cerebrum versus cerebellum. It means little brain. Cerebrum is brain and cerebellum is little brain. So they look a lot alike, they spell a lot alike, they sound a lot alike, they are not remotely interchangeable. And I'm still looking at the camera even though I'm not video recording myself at the time. So have it. And then the central canal is the part that continues down the spinal cord. And we talked about the central canal when we talked about the ependymma that lines the inside of the ventricles and the central canal. They're a layer of ependymal cells that help monitor the CSF and actually, along with the choroid plexus, make CSF. Okay. Oh, ventricles and the central canal, sorry, are lined with ependymal cells. Got ahead of myself. And ventricles and the central canal are filled with CSF, which also circulates in the, and this is a conversation I don't think we've had yet, in the subarachnoid space. So this is very important functionally and also test-wise purposes because there are two places to find CSF: the ventricles, central canal, and the subarachnoid space. Very important information. When you do a spinal tap, you're actually trying to get the CSF out of the subarachnoid space. So clinically speaking, it's maybe more important, although if you have a buildup of fluid in the brain, it's here at the ventricles where it's going to be a problem because they will actually swell and put pressure on the brain matter around them. They just squish the brain when you get too much fluid, so that's a thing. Okay, so let's talk about protecting the brain. We're on section 14.2. The brain is protected and supported by cranial-meninges, CSF, and the Better Business Bureau. What? That's not what that stands for? Oh, it's the blood-brain barrier. Oh, okay. There are 3 layers of cranial-meninges. Which mater is the, okay, let's do dura first. The dura mater is the most superficial. And again, these are all lab terms. That's still yellow. Cyan. The dura mater is the most superficial, and there's actually 2 layers of dura mater. And the superficial layer is continuous with the periosteum of the inside of the cranium, which I kind of need to know. Yeah, okay. Moving on. The veins of in the folds of the dura are called sinuses. So we've had the definition of the word sinus, and we said it was, well, here's one right here, is the frontal sinus, and there's the sphenoidal sinus. So this definition of sinus is a hole in the bone that is normally filled with air. And now we're adding a second definition of the word sinus, which is a fold in the dura which is filled with blood. So it acts as a vein. So this second definition of the word sinus is in a space between the layers of dura filled with venous blood that acts as part of venous circulation. So venous circulation, circulation means the bloodstream. So venous circulation is the circulation in the vein. Arterial circulation is circulation in the arteries, and general circulation means both arterial and venous circulation, just so we have those terms down. Veins in the folds of the dura are called sinuses. Next is the arachnoid mater, and yes, it's mater like toe mater without the toe. Arachnoid mater. And what circulates in the subarachnoid space, right here, CSF. You got it. And then on the surface of the brain itself is pia mater. And you can see next is cerebral cortex. The pia mater acts as the surface of the brain because it sits on top of the cerebral cortex, but it's a simple squamous epithelium. It's a single layer of completely flat cells. If you've ever cut an onion, in between the layers of the onion, sometimes you get that really thin layer that's completely see-through and completely flat, like that. Like that, a real thin layer. Except, of course, we don't have cell walls. So pia mater is the most deep, the deepest of the layers. The pia is the only meningeal layer that extends into every fold. That is true. The arachnoid mater on the models is the white shiny layer. And under the arachnoid mater, you can see the blood vessels. The blood vessels run in the subarachnoid space between the arachnoid mater and the pia mater. And the pia mater actually goes into each sulcus and the fissures. The arachnoid mater does not. All right, so that finishes ANP1 Lecture Test 5, Video 19 on page 20. Again, I apologize for my lack of video. I'm hoping that this will make it easier for it to actually record, because I'm tired of recording the same videos over and over and them not recording. So we'll see if this works. Thank you, as always, for tuning in. The education must go on. And as a reminder, when learning, and I'm learning here too, frustration is simply a part of the process. And you're frustrated, and you figure out what the problem is, and then you look for solutions, and then you move on. Take a break if you need to, but come back to it. Don't let frustration stop your process. Okay, that's all I'm going to say about that. So, it's good to virtually see you here. There was something else I was supposed to say. Yeah. Okay, fingers crossed this records. Dr. J out.